Okay, we'll be starting now, so give this man a big applause, the man who will be fighting the cloud. Łukasz Biały, Besom hands-on infrastructure and as code in Scala 3.
Thank you. I was introduced already, so I won't be talking long about that. I'm Łukasz. I'm principal software engineer at VirtusLab. I work mostly with Scala. I do functional programming. I'm actually an enthusiast of functional programming too. And I work mostly in my day job on distributed systems using functional programming, using Scala. So let's go quickly through the agenda because we have a lot of to do today. So I'll very quickly remind everyone what Pulumi is. Then I'm going to try to code live. That's probably going to go very well because I obviously have no idea what I'm doing. And based on today's preparations and experiences during that, I think nobody has any idea what they're doing actually. That is a lie. I'm not going to work on DigitalOcean. Sorry for that. I'm going to work on Hessner. And I did start working on Hessner not long ago using those APIs. So I'm very sorry for all of that because that's gonna be messy. Obligatory name because obviously we have to have one. And let's talk about Pulumi. So what Pulumi is. Pulumi is a way to work with cloud environments or more generally work with anything that you can provision, any resource that is managed by something else using your favorite programming language. In this case, we are talking about Scala, and Besom is Pulumi Scala implementation. It's an SDK for a language that talks with Pulumi engine and allows you to work with multiple different environments. You can work with cloud. That's the most obvious thing that you can do with Pulumi, but there are less obvious things that you can do with Pulumi. You can manage software as a service platforms. They also have resources, so you can manage them. You can manage databases with Pulumi. They are services. They have resources in them. Why not? So Pulumi allows you to work with resources in a declarative way, and given that we are using Scala, it allows you to use functional programming to do that. Let's take a brief look at this awful TypeScript example of Pulumi. So that's the basic shape. I think that some of you might recall this slide. That's mostly the same thing. It's just AWS getting an MII image name, creating a security group because you have to, and then creating an EC2 instance with Cloud Init script. So the most important thing here is that you are using your normal programming language. There are multiple programming languages supported by Pulumi. VirtusLab is currently maintaining Pulumi Kotlin and Pulumi Scala. You use normal constructs of a programming language, and there's a DSL that looks like this thing here. I don't see, you see this. So you declare resources that are sort of like objects. In Scala, that's a little bit different, but usually they look like just a classical object. Pulumi is also composable in a way that your programs can have exports. And that's the last thing that you see here. So exports allow you to create some output values that some other Pulumi program can use by importing your stack. Stack is an instance. It's a deployment of your program. So you write a program, it's a declaration of what you want to get, and then you apply it and you get a stack. So each stack can be imported and the output values can be reused. Therefore, you build in a very similar way as we would like to have things in functional programming. You build things out of smaller things. You compose stuff. Very quickly, let's go through how it really works. We have two buckets here defined. That's still JavaScript. But the important thing is that we get two endpoints out of that, two URLs, and we export them. So what happens when we run this? When Pulumi app starts, it goes through user's program. It's asynchronous, so it goes very quickly through the program, finds all the resources to declare, and sends those registration requests back to the engine, and the engine makes decisions about in what order and how to declare those resources using service providers. So it's a microsystem that runs on your CI on your machine that is composed of multiple programs. There's your program, there's Pulumi engine, and there are multiple programs running as gRPC servers that are actually doing the work and talking with cloud. So Pulumi engine orchestrates what has to happen. It then executes requests to the service providers, waits for them. If you have any lambdas or you have any values that you depend on, like in this case, you have website endpoint used 2 times, it's an output value on a resource. When this happens, you have to wait for those values to become available. That's the interactive part of using Pulumi. It's declarative, but allows you for dynamic work, allows you to do stuff with values that will only appear during runtime. And you can do whatever you want with those, values, because you are using a fully blown programming language. And you can even while true if you want, you can hang it. They don't care. So only when those values return from asynchronous processing in the Pulumi engine, your program is restarted. I mean, it gets back to the execution because basically in the implementation we are resolving promises basically. So those outputs are provided, and then the lambdas that you have scheduled to do to be executed on those values only then complete and only then are executed. When your program completes, in this case, it registers stack output, so it's those 2 exports here. Pulumi stores information in its backend, in its storage backend, about the state of your program. Every operation that happens is stored on the way, so everything is also rollbackable. If something happens and Pulumi knows about the fact that it happened, it will know in the subsequent execution that this operation has already happened and it doesn't have to be completed again. So that gives it transactional execution, and then you can also, given that those are just programs, you can just store them in Git. You can roll back to previous state, and Pulumi will be smart enough to make a diff. It will tell you what is going to be changed. Okay, once the exports are done, everything shuts down. Pulumi prints you a very nice report of what has changed. And that's that. So let's talk about the main stuff out of which Pulumi programs are built. So the most important bit is definitely the output. Output is a value that can be used, bear with me, as an input. So output is something that is a value that can be reused, fed to other resources as a parameter. You can define your own outputs, and all the resources in Pulumi declare outputs that you can reuse, you can work with them. Outputs are defined in terms of monads. In this case, they are an asynchronous data type because everything happens asynchronously in Pulumi. Underneath, there are things like promises in JavaScript, there are tasks in C#, there are completable features in Pulumi Java. In our case, we have ZIOs, we have cats effect IOs, and we have features. Okay, so there are some differences between how Pulumi works with Scala. So you might recall that all the lazy monads in Scala have this property that if you run them multiple times, if you reference them multiple times, they are evaluated multiple times. We can't have that in Pulumi because we can only execute a registration resource for any resource only once. So resource constructors in Pulumi Scala are a bit different, and they are probably a bit surprising for functional programmers because they are memoized by default. So you get an output when you create a resource, but that output is going to be evaluated only once. Okay, so the DSL is based on the premise that we want to limit side effects that are not output registrations. So that means that in Besom, the whole DSL is purely functional. Like I mentioned, outputs are defined in terms of IOs, in terms of ZOs, and in terms of features, depending on which module you want to use. Pulumi also executes the programs in two slots, in two segments. In the first run, it checks your program for correctness. It's a dry run, and only then, just like Terraform, and only then your program is executed on the live environment. Okay, so what is very nice for functional programmers here? Pulumi gives us the ability to define custom components. And that means that you can, as a programmer, encapsulate a bit of resources that you want to have as a consistent bit, as a reusable consistent bit. Let's say you want to have a deployment of Redis on Kubernetes, and you want to only parameterize it with few values, and you want to manage it together. You want to have it in a bag. Pulumi gives you the ability to do this. So the property of Pulumi being composable goes even deeper than just stacks. You can reference stacks, but you can also have components inside of stacks. That allows you to reuse a lot of stuff. And it's sort of similar to Terraform modules. A unique feature of Pulumi is that there is automation API available. An automation API does something completely new, I would say, on the market, and allows you to embed a Pulumi program inside of another program in your programming language. The most interesting use case, I would say, to use this is a situation where you are working in cloud, obviously, in a scenario where you have multiple customers that you want to separate. You can embed Pulumi programs and run them when you are setting up platform chunks. I mean, I'm missing a word here. Sorry, I can't remember. Either way, it allows you to just trigger creation of closed environments for your customers from your normal application, from your management application. You can do this programmatically. You can, and most importantly, Pulumi is the service that manages state. So this survives migrations between versions of your application. It works seamlessly because Pulumi manages state. Another nice thing, which probably makes the most sense in corporate environments, is that Pulumi has a module called Crossroads, I think. This module allows you to enforce policies. What it means, so like I mentioned, you're using a fully blown programming language, and you have state. Pulumi has access to state of all the resources that you have deployed in any given stack. That allows you to write functions, and that's something that we want to implement, and we don't have that yet in Pulumi Scala. That allows you to basically iterate through all the resources that Pulumi has created in your stacks and apply policies to them. Basically apply predicates to them or apply changes if you want to, for instance, enforce a policy and, let's say, mark all the resources in Kubernetes with a label. That can also be done. Okay, so Besom. Let's try and build something. I'm not completely sure what will happen, given that I have seen at least few completely new errors from Pulumi today. That's probably why I shouldn't have updated the version of Pulumi yesterday. Either way, there is no easy way to roll back, so we're just going to have to see what happens. So that's my account on Hetzner Cloud. I'm a tinkerer. I like to hack things up, but I don't like to pay, well, it's not maybe an anti-corporate sentiment, but I don't like to pay big bucks to AWS or Google or especially Azure. Either way, I'm using Hetzner. Hetzner is quite cheap and it's quite versatile, works very nice. And the most important bit is that there is a provider for Pulumi, for Hetzner, so I can do my stuff in Hetzner. This is the dashboard in which you can see that I have my private instance here. It's basically sitting there, idling and just making a bill for me, but today we're going to create more of this stuff here. Okay, let's switch. Can everyone see what's going on here? Readable? Cool. Very nice. Sorry, I'm not going to look at you because there's this light, and I asked them to, dim it a bit. They didn't, sadly. So I basically can't see anything in that way. So I'm just gonna focus on my monitor. Okay, so the basic idea of what we want to build is to do something interesting. On the previous conversation we had on this conference, I've demonstrated that we are able to deploy stuff to Kubernetes. And we actually did. But this was local Kubernetes. This was Kubernetes managed by Docker Desktop on my machine. So it's not very interesting. It's just, oh, okay, you can deploy something to your laptop. Cool, right. But today we are going to do something completely different. First of all, there are going to be multiple nodes. Second of all, it's going to be in cloud. So where do we start? I'm going to actually cheat a lot because last time I did live coding, I was told that, well, you're losing a lot of time typing. That's true. So I'm basically going to, I'm going to cheat. I didn't do that. That's actually, oh my God, it's even smarter than I thought it is. Okay, so apparently it seems that if you have a file with complete implementation in the same directory, GitHub will just tell you what to type. That's very nice. So we are going to start with defining locations of the servers where we want to have. As far as I know, if we don't want to cross the Atlantic Ocean, we can only use those 3 locations. So they are basically in Germany, and this one, it's Helsinki. So we're going to create a cluster that spans a bigger chunk of Europe. So next thing that I have to do is I have to create an SSH key so that Hetzner can let me into my servers, basically. Okay, yeah. That was a quick typing session. Okay, yes, and obviously when you have an SSH key, you also need a private key. So we have to have this thing here. SSH keys are necessary, like I mentioned, to access your server. Private key has to be, oh my God, are you going to just type everything? Okay, I'm not gonna spend a lot of time typing. Either way, we want to create a server pool. Okay, come on, just don't do anything else. Cool. So we want to have a server pool. We want to have 3 servers because I'm poor. I can't afford more. So we can, do normal Scala. We can just create a range and then map it. There's an index. Very nice. We can create servers. So those things are the details that you have to provide. They are nicely typed. So they're not as nicely typed as we want them to be, but we're working on that. So that's going to be better. Either way, comparing to the last time I talked here, there are improvements. For instance, you can do this. This is actually non-empty. Oh my God, what is this? No, it's not that. No, it's also not that. Cool, doesn't work. Maybe if we go here, yeah. This name is a non-empty string. And the improvement here is we are working very hard on macros to allow you to precisely work with types as they are defined with the rules. So in JavaScript or Python, you wouldn't get compile time checks, but with Besom, you get additional checks, and we're working on more of them. When you need to be sure that, oh, you can't pass this value here. Given that the other side is mostly using Go, so the providers are mostly written in Go, that leads to some interesting discussions with Pulumi team, but hell, we're doing our best here. Either way, we create a CPX11 type of the server. I don't recall which one that was. We could possibly go here and check what Hetzner does have in this box. CPX11. Oh my God, it's not even in the table. Interesting. Either way, it exists. So we want to use a base image of Ubuntu from the previous year. The names are important because those are the actual names that are going to appear in Hetzner's dashboard. This field declares the name inside of the environment of a cloud provider. We're also going to spread them between all the locations, use the SSH keys to create that, and declare that we want to use IPv4, but not IPv6. That's cool. Okay, so the next bit is, you know what, let's maybe stop our nice friend here. Okay, we've done that. And oh my, cool. That actually means that we are missing, yes, an import. Okay, and we're missing server args. Let's see whether this works. Cool. Okay, compiler is happy. Let's try and see what happens here. I'm absolutely not sure what's going to happen. So Pulumi asks us for a password because Pulumi keeps secrets encrypted. So it kind of works like Ansible Vault, for instance. Your secrets are encrypted. The rest, they can be put into GitHub. Obviously, if you are using pass as a password, as I am, don't do that. Oh, yes. So my compadres from my Pulumi team told me about that, and I didn't do that. I didn't put additional flags. So we have more flags now because we are using Scala 331, and we can ask the compiler to detect the problem that I have just created. So the problem, quite obviously, is that it's functional programming. There are no side effects if we are not, returning a value. So in this case, I'm not returning anything. I have just declared that we want some stuff to lay in the memory. So let's change that, and let's actually try and do that. If I had actually listened to my friends, we would get a nice, let's maybe try. Does anyone recall what is the flag to enforce missing values? No? Okay, let's not try that. Yeah, but the problem with Copilot is that it only knows about stuff that wasn't released like 3 months ago. So, not gonna happen. Okay, either way, we need to export that stuff. And that's a vector of output of server. So functional programming to the rescue. We need to know, we need to have servers. So we need to sequence, basically traverse the server pool, and that gives us output of a vector of server. Okay, and let's maybe try and get IPs. Do we need to do that? Oh, come on. And that's an output of a string. Okay. Okay. Okay, let's try and see. This, oh yeah, very secure password. This should create those servers for us. Yes, it works, obviously. Oh, it's already used. Oh yeah. You've never seen this? Okay. Seems that we are in the business. Yes. And you can see that Pulumi has also stored the outputs. So if we wanted, we don't, but if we wanted to reuse the values that we have just outputted in, let's say, Pulumi program written in a completely different language, like YAML, it's possible. I don't approve, but it's possible. You could just import those IPs here. So that's a very nice feature that Pulumi offers. It's multi-language, and all the languages can talk to each other. Okay, so we have 3 servers. That's very nice. Let's try and see whatever. Oh my God, what macOS? What's going on? Let's see whether we can deploy the K3s on those servers. Come on, and now the silent treatment. Yes. I have no idea what I had in mind here. Maybe, oh yeah, he reminds. He remembers. Cool. So what we want to have a Kubernetes cluster, and we want to have it in a way that's easy to work with. I'm familiar with deployment of full Kubernetes. It's a very interesting thing to do, but thankfully to people at Rancher, there is something called K3s. So K3s is actually a bit different, and by different I mean it works. How it works is kind of interesting, but to cut the long story short, K3s stores the whole Kubernetes, the whole thing, in a single binary. So it's very easy to install, very easy to manage, and it's perfect for tinkering or things that are, not exactly humongous. You don't need a GKE to run everything. You can have something smaller. They say that it's good for CI, IoT, Edge. I use it as my main driver, so maybe I'm edgy. Either way. No, we don't want the table. Yeah. Either way, we are going to deploy K3s. So actually, the installation of K3s, it's very simple. This is installation of K3s. And I know what you might think, doing platform engineering by randomly, executing shell scripts pulled via curl from the internet, it's probably not the safest way. There are better ways. I'm not lying. There are better ways to install K3s. But if you are tinkering and just want to do something completely random, that's fine. We can work with this. So let's see what our good friend Copilot has to say here. Okay, so from what I recall, I'm going to jump the shark and just tell you that we're going to define a component, but we're going to go step by step. Okay. Okay, steps? No? AI. Yes, world class. Okay, let's just go here and see what we have to do. Cool. I think it will just start working. No? Reliable. Okay. Let's go and copy. So, maybe it's indignified because we have done that manually. Okay. Yeah, so we have to choose a leader. K3s is a bit different from Kubernetes in the fact that it allows you to do something that Google wouldn't approve of. It embeds an SQLite database inside of this small one binary, and it uses it to actually manage the whole thing. So it is possible to have a single point of failure with Kubernetes, with K3s, and that's exactly what we're going to do. We're going to have a single leader and 2 followers. So as you recall, this thing is a vector of 3 nodes. Yeah, don't yell at me about the head and tail thing, okay? We're just hacking. And then we have to do something. Yes, we have to connect. So you might recall, but obviously he doesn't. You might recall that we used my SSH key. And we created that SSH key inside of Hetzner, and we now can access those machines via SSH. So that's the place where things become more interesting, in my opinion, especially, because usually when you think about tools like Terraform or Pulumi, they are based on cloud resources, stuff that can be created only via API call. But that's not exactly true. Pulumi has a package called command that allows you to do stuff by hand. It allows you to declare resources in a declarative way, but actually run bash underneath. And I think it's beautiful. So we are going to do exactly that. The first thing that we have to do, come on, Copilot, catch up. Oh, yeah, beautiful. We have to define, yes, obviously. We don't have it yet. Besom API command. If I do that, will it explode? Probably. Oh, come on. I know it doesn't compile. Cool, now it compiles. So we are defining a connection to the leader because we have to start with the leader. Why? It's important because in the K3s way of doing things, first thing that you have to do when you're deploying the cluster is that you create a leader, and leader creates a token. And that's very nice because that's the only thing that you have to pass to other nodes. Obviously, they need to have connectivity in the network. So if you have firewalls there in enterprise environment, that's not going to work. You have to also punch holes through the firewalls. But if you have unconstrained access to those machines, as they would be in a single resource pool, you can basically just connect them together. And the token is the only thing that K3s needs. So let's go and just, deploy. Are you going to work with me? Oh yeah, come on. Okay, so we're going to define a command. We're going to call it, that's the Pulumi way. We're just calling bash, but we have to name it as a proper resource. And then this command is going to use the connection to the leader, and then it's going to call that curl, and it's going to, evaluate that. And because we are very safe and secure, we are using WireGuard to, encrypt the communication between nodes. The important bit is that you can define the inverse operation, and that's important because once you decide that you want to drop those resources, in this particular case, commands, you want to run the inverse commands that, revert your operations. In this case, K3s has a script called K3s uninstall. So we are just going to tell Pulumi to just call delete with this script, and that's going to be fine. Okay, so next bit, we have to now take care of the token. We have to obtain the token, and we're going to leverage the fact that we can access outputs on the resources. So this is an output of command, and we can just flat map on that. Its output is a monad, so we can just use flat map yeah. Did I do that? I think not. Maybe I did. Either way. That's not completely right, but let's try and see. That's what's beautiful about hacking. Trying and seeing what happens, what explodes. So to fetch the token, we're not going to do anything magical. The only thing that we need to do is to just read the file that K3s has magically created on the node for us. I think that's not all, and I would be very surprised if it was. No? No, that's not that's not correct. I think we also need. That's surprising because it seems that that's in my previous. No, it's not in my previous implementation. AI is lying, ladies and gentlemen. Yes, obviously. So now it's quite an important bit of working with Pulumi. So as I mentioned before, everything is asynchronous, and it's not exactly as you would think, because most of the time, functional programming people tell you, okay, so flat map makes things sequential. Well, no. So actually, due to the semantics of Pulumi programs, you have to inform Pulumi about stuff that is going to be sequential. And we can't do this any other way, sorry, because if we did, everything would be sequential, because we are doing functional programming, so everything is flat mapped. That way, what we have to do is we have to inform Pulumi about the ordering. And we do this by defining a custom resource options with depends on flag, and we then just inform it about that it has to wait for resolution of this command. Actually, I think that this is completely unnecessary. So we can just remove that. And we'll see. Maybe it will explode, or maybe not. Wait, what? Okay, so was that working? Oh my God, what's going on? Is that just a map? It's probably, no, it's, yeah, thank you. It's standard out. Okay. And like I said, we probably don't need this at all. That's just something I forgot to clean up. Okay, so we have the token, and no. Oh, really? Okay. You know what? I lost my trust. Let's check that. Yeah, it looks fine now. Okay, so the next bit is we need to fetch kubeconfig. Kubeconfig is the file that defines all the properties necessary to use kubectl with a newly created cluster. We are going to need this kubeconfig file to be able to see what's going on in the cluster from our machine. Okay, next bit. Oh yeah, we're going to work with followers. Okay, so we have two followers, and we also have to create K3s instances on them, but we have to pass the token that we have here inside of this value as an output of the command. Are you going to work with me? No? Come on. Here. Nope. Unhelpful. Okay, well, it's logical. We have to create new connections. So, as before, we are going to just map on the remaining two servers. We are going to create a new connection per follower, then, oh yeah, cool. Hopefully that's right. Okay, so the token is here. The URL to the master is also here. Well, our safety net is here also, that's nice. And everything else is just as it should be. We also want to wait for the leader to be created. Actually, we could wait for the token. That would make more sense. But, you know, no. What's wrong? Okay, it wants to wait for the leader. I'm fine with that. I'm fine with anything if it works. Okay. So, the next bit is a bit different. And that's mostly because we are still working on it. Okay, is this fine now or not? Yeah. Okay, so let me explain this bit. So we need to create, do we? Oh my God, it's, no, not gonna work. Bad copilot. So let me explain this again. So as I mentioned, in Pulumi, even bash commands are resources, and that means that they have, as resources, unique identifiers, URNs, in Pulumi parlance. And Pulumi won't allow us to have duplicates. If you have duplicate resources, Pulumi just throws the towel and, no, I'm not going to work with you. You have to change it. And here's an interesting bit. So as of now, there is no Pulumi SDK that allows you to use outputs as names of resources. And that's a big limitation. I'm not sure whether Pulumi is working on getting that to work, but that's something everybody is complaining, and that makes sense because look here. I'm using interpolation. It's not a standard Scala interpolation. It's a special Pulumi interpolation, and there is, by the way, let me see, maybe it works. Yeah. If I try to do this, yes, we have an error for ends. Can you see? Oh, I don't think you can. Let me get it a bit. Can you see the error? Oh, cool. Good eyes. I can't. Either way, we have compiler plugin. You can see it being added here. Disregard the snapshot. We are on the bleeding edge. But the compiler plugin tells you, that's another nice property. You don't get that with any other language at the moment. If you try to do something stupid and interpolate an output, which is like a future or I/O asynchronous value, in a normal string interpolation, which is synchronous, that's not going to fly. You are going to get a garbage string. And that happens in any other SDK. If you do something like that, you only get notified about how you messed up when you run that. And if you do dynamic stuff, if you do stuff that depends on other stuff, you only get to know about that after the dry run. That's not good. We want to, prevent such stupid foot guns. So we have a way to prevent that error. And you can see we can't do that. We can't just interpolate an output. That wouldn't make any sense. You have to use p-interpolator, which allows you to interpolate a string asynchronously. So the output of this interpolation is, again, an output. Yeah, redundant, sorry. Either way, we don't need this anymore. So it would be much nicer if we could just put an output here, but that's on my backlog. Sorry for that. We haven't fixed this yet, but it will be fixed before version 0.2.0, which is going to come out soon-ish. Either way, we have to, in this particular case, create a non-empty string to be able to pass it here because of type safety. So yeah, fix this in SDK, definitely. And the other stuff is probably understandable. We just fetch a dump script from somewhere in the internet and just run it, because why not? Okay, I think that might be all in this regard. Yes, at least for that bit. Okay, so we can probably reuse this because we're going to make a component out of that. And I think, yeah. Oh, it doesn't work. What are you doing? No, we're just going to copy that. Okay, so quick explanation what we're doing here. So kubeconfig file that K3s generates is basically done only for localhost. It's made with the assumption that you're going to SSH to the machine on which K3s is installed, and you are just going to use kubectl there. We don't want to do that. We want to do stuff remotely. It's, 23, the current year, basically. And to do this, we just have to make small amendments in the content of the kubeconfig file. So that's a very interesting bit, because you can't do this with Terraform. We're just waiting for the kubeconfig file that will be created on a cloud server, and we get it, we just fetch it, and after we fetch it, we modify stuff in flight. We just replace the default with a cluster name, so we are able to call to the cluster. We can name it, and we are replacing the address with the address of leader, which has the whole control plane. Okay, and I think we are very nicely. Yeah, I think that's the whole thing. So this is the point where we create the case class that I have defined before. And let's try and see whether this actually works. Now, it might work, but no promises are made. Yes, pass. Please. Wait, what? Oh, yeah. I really should have added those flags. Yeah, let's go and see What else did I do here? Okay. So, funny thing is, you end up, in most of the Besom programs, you end up with a for comprehension. Oh, come on. And node, what was server IPs? Maybe we can live with that, and it won't change anything. Either way, let's try and see. Okay, so you can see one interesting property here. We aren't creating the nodes because they exist. So the only operations that have to be created, and Pulumi sees that on a diff, is that we have defined that we want to create a K3s cluster, and we have to create the leader, then fetch the token, and start the K3s. Oh, I forgot one thing. Yeah, we could do something more interesting. What was the syntax? I think it was just, oh, you know what? Let's be lazy. Interesting bit is it's probably not going to work for me, and I screwed myself. Because it's not going to, oh, yeah, does it? Okay. Yeah, that's nice. For everyone streaming online, you haven't seen that. Either way. So we have the kubeconfig locally. We're just gonna do some magic tricks to be able to work with that. I think it's, yeah, tell me dev. Yeah, cool. And we can see what's going on. Get pods. Okay, here's our cluster. Seems to be alive. That's nice. Okay, so we have a cluster. We can do stuff with the cluster. We can deploy something to it. So, yeah. Where's the helping AI hand? Oh, yeah, no. Okay. So basically, let's start with the namespace. Okay. And let's start with the imports. I'm gonna just cheat a lot because I think we are slowly running out of time. So let's just put everything here. And yeah. And now it works. So first things first, what we have to do is we have to create a namespace. We could do all of that in one go because Kubernetes resources are something that you can just, oh, unchanged. Yeah. Yeah, no. Oh, well. Obviously. Okay, so we have a namespace. Is it liftoff? Yes, it's liftoff. Cool. So we have a namespace. We have created it. You can see it here. Here. And let's see if AI is in the mood. Is it? Oh my God, it's not. Okay. So the next bit is that we want to deploy an Nginx. We want to deploy some web services. So we're going to create the config map to store information, to store index HTML file that we want to serve. And yeah, basically the only missing bit is that we have to create it here. Okay. And now it's the time for Nginx deployment. Silent treatment again. Oh, because it's after enter. Let's see. Let's make it. Come on, no. Nope. Okay. So I'm going to assume that everyone is sort of familiar with Kubernetes and knows how deployments work. We're just defining managed deployment with one replica. We can have more, actually. We have a full cluster, so why not? And we are passing all the necessary stuff in a typed way here. So at least you don't get, YAML errors with indentation errors. Either way, we can just apply that, and this should pass. This should create, oh, it won't do anything. Because, yeah, I really should have used the flags. Yeah, unchanged. I know, sorry. Okay, cool. So we also have a deployment, and let's see whether we actually have it. Get pods. Yes, we have 3 instances of Nginx. Very, very, high availability deployment. And what we actually do need is a service to actually expose them. So let's quickly put that here. Fix indentation. And it's not. What's wrong? Indentation is wrong. Okay. As we see, that's an Nginx service. Cool. So again, we deploy. Okay. So at this point, we should have an ingress. And I mean should, I'm putting the emphasis on should specifically because I've been typing furiously before my presentation, trying to resolve a bug that we found. Sadly, ingresses don't work yet, for now. Or maybe it's just this particular scenario. Not exactly sure, because I wasn't able to fix that. Either way, we had a full deployment, so let's try and see whether we can just access one of the pods and connect to it and see whether everything is working as expected. Will it work? No. Um, 80 to 80. I think it's the other way around. Nope. Oh, yeah. Okay. Yay. Okay. So, as a quick summary of what we have done, we have created servers on Hetzner. We have deployed Kubernetes deployment on them, and it's running on its own. It's free. It can do whatever it wants. But we have also tasked it with running our workload, and yeah, we have our workload running. So let's. If some of you were here just before my talk, you might have heard me laughing, and that's because I'm not exactly sure what's going to happen. Last time, I got a 6F. Okay, let's try and roll back the whole thing. Oh yes, thank you, Pulumi. Did I mention that core Pulumi is written in Go? Yeah, so sorry for that. That happens sometimes. Let's just kill things manually. And I'm listening to your questions. Yeah, wait, obligatory thank you slide. Questions?
Why even bother with non-empty string if it has a dry run?
Could you repeat that question?
Why even bother with non-empty string when it has a dry run before?
Oh yeah, sure. Good question. Yeah, it would seem redundant, but the thing is, Pulumi programs are dynamic, as I mentioned. So that means that when you are creating resources, you can do stuff as a reaction to values that you get from cloud. In most scenarios, things are declarative to the level in which you don't have to worry about that. You just declare everything, and you don't react to anything that comes from the cloud. But that isn't really true. In practice, this is where tools like Terraform or Ansible lack elasticity, and they need special plugins, hacking, custom providers, things like that, to be able to work with values dynamically. Pulumi gives you this power because you are using fully blown programming language, but on the other hand, that means that your program can have values that only arrive during the program execution. And we just had this case here because things are not possible to, to work with until they are created. Good example here is that we can only work with those values after previous bits are done. And those bits are created dynamically. If we were to create the whole thing one more time, you would see that the dry run doesn't really tell you about the stuff that it doesn't know about. And it doesn't know about it because Pulumi substitutes all the values that are going to be known in the future during deployment with basically empty outputs. And empty outputs have the semantics of none from Scala's option. If you flat map or map on them, there's nothing happening. They just short circuit. So to have type safe programming model, we have to check as much as we can in compile time, and that's our biggest focus. We're trying to disable the user in terms of making foot guns, of shooting his own foot.
Okay, we're running a bit late, so give big applause to Łukasz. It takes a lot of bravery to run Golang code from Scala, as you saw.